Hey, what's up? Welcome back to another episode of Andrew and Amandeep, the show where I respect Mr. Bhutar's patience in dealing with us. So, today we're going to look at addition and subtraction rules as well as the constant multiple rule, and these are rules you are already familiar with. We've seen this in when we're taking derivatives, in that if I were to ask you to take the derivative, right, of two functions, let's say I want to find the derivative of f of x plus g of x, right? And so, like, okay, what can we do? We can separate this out. We can take the derivative of f of x, right? And we can add that to the derivative of g of x. This is a property of derivatives. And this is fine. You're allowed to do this. And of course, you're allowed to do this with minus as well. And so, such a basic rule is also holds true for integrals as well. So, if I were to ask you to take the integral of f of x plus g of x, with respect to dx, you can split up the integral into two parts. You can first take the integral of f of x with respect to dx and add that to the integral of g of x dx. So that's the idea. It's pretty simple. It's the same as differentiation, where you're allowed to break it apart. And of course, again, you're allowed to do this with minus. You're just allowed to break it apart like this. And this can be helpful sometimes. Let me give you an example. What if I wanted to take the derivative, sorry, not the derivative, the integral of this function, x to the power 4 plus x to the power of 2. Let's do that. So how would you go about doing this? Well, you could, again, split up the integral into two separate pieces. So let's work through this. We're going to take the integral of x to the power 4 by itself and add that to the integral of x squared. And now let's work through this. What does this integral become? Take a moment, pause the video, and see if you can figure that part out. Okay, so I hope you figured it out. And if you didn't, it's okay. We follow the same rules we learned last time. We're going to increase the exponent by 1, and we're going to divide it by that number. Like that. Sorry, let's get rid of the integral sign. That doesn't belong there. Okay. This is equal to x to the power 5 over 5. Because once we take the derivative of this, the 5 we'll subtract 1 from it, leading us to this 4. And we will also be left with a 5 as a coefficient, which will cancel out with this 5. Now let's do the second part. So you should be able to do this fairly quickly because, well, we just did the rule. So it's x over 2. Sorry, x squared over 2. There we go. Oh, wait, no, it's not x squared over 2. I lied. Okay, let's do this again. This is x cubed, because we need to subtract 1, over 3. There we go. Sorry. And, of course, don't forget the integrating constant. You need this. So, this is our result. Okay, moving on to the constant multiple rule. This is the same idea as well. We learned this in derivatives. If you take the derivative of, say, let's do this with a square bracket, of a constant times f of x. Okay, that's a c times f of x, where c is a constant, right? We can take the c out of the derivative. So let's write c d over dx f of x, like that. Oh, okay, we're back. Just like that, okay. And you're allowed to do this because c is a constant. And the same applies for integrals. So we have the integral of c f of x dx. You're allowed to take the c out. C, and you just take the integral of f of x. Oh my gosh, we are not having a good day today. Okay, here we are. Okay, so, well, this is a simple enough concept that I'm not going to give you a practice problem. Just remember that if you have something like a constant times a function, you can always just take the constant out of the integral. It's the same idea as the derivative. Anyway, thanks for joining us today. Join us next time when we talk about, I don't know, it's going to be something about integrals. But yeah, check that out.